Welcome to the wind tunnel lab. First I'm going to talk a little bit about pitot tubes, which is going to be our main source of measurement, how we measure wind speed in our wind tunnel. We have a pitot tube right here. It's attached to a slide that can move up and down, which we'll be using later in the lab. And pitot tubes have essentially two output tubes. So one of the output tubes has little holes that are drilled around the outside, around the perimeter of the pitot tube. And I think you've talked about these in your lecture. And those essentially will only measure static pressure. If you remember back to the Bernoulli lab with the holes that were drilled perpendicular to the flow that were attached to the manometers, those also measured static pressure. It's the same thing with the pitot tube. And then we also have a tube that's pointing in the direction of the flow. And so that is like the hypodermic needle that we slid into the Bernoulli device. So that measures total pressure. If we subtract the two, we get dynamic pressure. And then we can calculate our velocity in our wind tunnel from that dynamic pressure. So the central tube here is our total pressure measurement. So that's going to be the higher pressure. So we're going to have to attach that to our electronic high pressure side and the high pressure side on the incline manometer, which is the left side. If the left side of our incline manometer is higher pressure, it will push the red fluid down. And then the static pressure side is this one on the outside. And so this is the lower pressure. This attaches here to our low pressure and also to the low side of our manometer. So now, essentially, our manometer and our electronic measurement will show the difference of the two, which is our dynamic pressure, and then we can calculate velocity from those.
All right, so I've gone ahead and moved the pitot tube so it's in the middle of our test section here. The idea is that we want to set it in the location where we'll have the maximum pressure difference. Because of wall effects that will slow down the flow, we know that the maximum flow velocity will actually be directly in the middle of this channel, and so that's exactly where we want the pitot tube to be, both in height and in the distance back and forwards. This pitot tube, as you saw before, Gordy had connected it to this manometer here, and so he's going to keep the camera on the manometer. I will go over and I will turn the wind tunnel on so that the motor is running at its maximum, which is 1800 RPMs. Right?
This is what's called an open channel wind tunnel. So basically, there's an air intake over here with a grate over it, and then the air flows through the test section here, which is clear so we can see it with the pitot tube, and then there's an outlet over here. And that's actually where the motor is. So the motor is actually sucking air through the wind tunnel and then throwing it out into the rest of the room. A fancier wind tunnel might have, I shouldn't say fancier, this one's pretty fancy, but it might have what's called a closed section where the air is recirculated around and fed back into the inlet. You tend to get slightly more stable wind speeds with that. For example, if somebody stands upwind or downwind of this, the wind speed inside the wind tunnel will change. So one thing we can do is we can measure what the inlet velocity is over here at the inlet, and then compare it to what the calculated velocity is from the pitot tube in the test section. And so we're going to do that now with a handheld anemometer.
just took and found the average, you should be able to compare it to the value you found for the velocity inside of the test section. Hopefully you found that the average velocity here at the entrance to the wind tunnel is different from the velocity inside of this test section. And what we want you to think about here is, how does the area of this cross section at the inlet compare to the area here inside of the test section? This should lead you to thinking about our continuity equation, where we're thinking about putting the same amount of mass through our system, but how is that affected by the fact that this area has changed? So see if you can puzzle through a little bit of how the continuity equation leads you to discover a ratio between these two areas, which will lead you to some further insight between how those velocities relate to one another. So we'll go ahead and notice here that from the bottom of our test section to the top of the test section is just about 21 centimeters.
20
and a half.
20.3 or something, yeah.
20.3. So if we go from here to where my thumb is right now at 30, then I'm going to reconnect it here, and we find that the test section inlet is about 35 centimeters.
So the next step in this lab is to do a study where we compare different RPMs. So we're going to change the RPM of the motor, which will effectively change the wind speed. We'll show you the RPM reading. We're going to do the sweep that's called out in the lab manual, and we'll show the incline manometer reading, and we're also going to take data on this computer. And so this computer is essentially just measuring a voltage output from the wind tunnel through a LabVIEW VI. And so we'll take 20 readings once every second, one reading per second, and then show the average of the voltage for that given RPM. So you can collect the data from the pictures that we're going to take for that.
Now that we've completed measuring the maximum pressure difference when our pitot tube is in the middle of the test section across an entire range of motor speeds, what we're going to do now is we're actually going to move the pitot tube. We'll start at the very bottom of the test section, and we'll move it progressively upwards through 5 different points so that we can find how the pressure difference varies through the wind tunnel. And while we're doing that, we'll also be taking voltage measurements using the computer.